So, good morning, everyone. Once again, welcome to Physics by Physics. And today's live session, we are going to discuss NET-JRF March 2025 questions of mathematical physics. So, we are going to solve all the questions that has been asked. So, we are going to discuss questions that has been asked in part B and part C. And in part B, they have asked 3 questions, and part C also they have asked 3 questions. So let's start with March 2025 paper. See, question number 1. So let's see this question. Now, I is an n cross n identity matrix. This is an identity matrix. And it is given that adjugate of twice of I is 2 power k is I. Then what will be value of k? So what is the adjugate of a matrix? So adjugate of a matrix A is given as, you have to find the cofactor matrix, and then you have to take transpose. So this is Cij and then transpose. This will give you a cofactor matrix. So you know how to write the cofactor of the matrix, and then if you take transpose, that will give you adjugate of A. So we use this when you are writing the inverse of a matrix. So inverse of a matrix is given by 1 by determinant A, and this is adjugate A. So from here, you should write this adjugate A will be given by, you have determinant A, and then you have to multiply with A inverse. So we will use this result. But here, this adjugate 2I. So this will be given by what? This is determinant. Use this result. Determinant of 2 identity matrix into twice of I inverse. Use this result. And you know the property of determinant. Determinant of some scalar into matrix. So if you know the order of the matrix, so then this will be given by 2 power n determinant I. Why? Because this is a scalar and I is a n cross n matrix. So this will be equal to 2 power n determinant I. And this will give you 2 inverse I. So again, this will be 2 n minus 1. Determinant I will be 1. And this I inverse is I. So this will be I. Now you can see they have given this value. This is equal to 2 power k I. So what if you compare both sides, k will be n minus 1. Is it clear? So in this way, you can solve this question, and option will be C because k is n minus 1. So try to write it down. Is it clear? So now we will see next question. See, next question. Yes. So in this question, you can see you have to find the value of the integral, this integral, over the closed contour C as shown in figure, where K is some constant. So this integral value you have to find. Let's say this value is I, this value you have to find. And this is given in, this contour is in anti-clockwise direction. So now you can see in this integral, let your function fz be 5 by z minus 2 whole square, and then you have sine kz. So this is your function. Now this function is non-analytic at z is equal to 2, because when you put denominator to 0, you will get z is equal to 2. So what will be z is equal to 0, z is equal to 2, this function is non-analytic. And what will be order? It's a second order. So z is equal to 2 is a pole of second order. Second order. Why second order? If you want to check, you have to see limit z tending to 2, then you have to write z minus 2 power. You have to see the lowest value for which this will be non-zero. Sine kz. So what should be the lowest power? Because if you take 1 here, then this will not be finite. But when you take 2 here, this will cancel out and you will get 5 sine 2k. And that is the finite value. So that is how you have to check order. So z minus a in general at a power n. So what lowest value of n will give you the order. So it's a pole of second order. So now we can use the residue theorem and just see where is z is equal to 2. Z is equal to 2 lies inside. Z is equal to 2 lies inside. So use the residue theorem and find the residue of the function. What will be residue of the function at z is equal to 2? So this is given by, you know, for n order, this will be 2 minus 1 factorial limit z tending to 2. And then you have, here you will get z minus 2 power 2. And you are getting here 5 by z minus 2 whole square sine kz. This will cancel out. And if you differentiate it, this will be 1. So what you will get? This will give you sine k will give you cos k. So this is 5 k cos 2k. Is it clear? 5k cos 2k. And then the integral value will be given by 1 by 2 pi. According to residue theorem, this will be 2 pi iota a minus 1, because there is only one point that lies inside. So this will be given by this value. So that is for your 5k cos 2k. This is integral value will be 5k cos 2k. So this is the integral value. According to residue theorem, that will be 2 pi iota sum over residue. So that's why option A is correct. 5a cos 2k. So this is the second question. Now we will see next one. Yes. Now you can see in this question, it is given that this particular sum of the infinite series is given, and you have to find the sum of the infinite series. What will be this particular value? What will be this particular value? So let's see how we will calculate. So if I take, let's say this is S, this value is T. T we have to find. So we will use a trick here. Let's see, find S minus T. So what will be S minus T? This first term will cancel out. Then just see, if you take difference, this term will cancel out. And this term will cancel out. Then this will survive. Then this will cancel out. Then this will survive. This will if you take difference, so what you will get? This is 1 by 2 power 4 plus 1 by 4 power 4 plus 1 by 6 power 4. Only these term will survive because S is given. So now you can see we have calculated S minus T. Now let's see, this is 1 by 2 power 4 common. So this is 16. So this becomes 1 plus 2 power 4 by 4 power 4 plus 2 power 4 by 6 power 4 plus and so on. And this is 1 by 16. Now this will be 2 power 8. So this again becomes 1 plus 1 by 2 power 4. 2 power 8 will give you 2 power 4, and this will give you 2 into 3. So this will give you 1 plus 3 power 4 plus and so on. Yes or no? And this value is 1. So again you are getting same value. So this is S minus T, and that is giving you S minus T is S by 16. Just see, this value is again same value S. So T will be S minus S by 16. So that is 15 by 16 into S. And S is pi power 4 by 90. This is 6 times. So finally, you will get pi power 4 by 96. Pi power 4 by 96. So D option is correct. Just see, just by rearranging these two equations, we have calculated the series, infinite series that has been asked. So note it down. Clear? So let's see next question. Now see. Yes. So this is based on the conditional probability. Class has 60% of boys and 40% girls. In an examination, 8% of the boys and 12% of the girls got an A grade. If a randomly selected student at an A grade, what is the probability that a student is a male? So let's see how to solve this type of question. So first we have to find what is the total probability of getting a grade A. So we will take, let the event, one event I am taking as a that students are boys. Okay? Student is a boy. Student is a boy. And another is G is student is a girl. Is a girl. And then next event I am taking that they got grade A. And take another event A. Student got grade A. So in this case, let's say the students, what is the total probability that the student got grade A? So first I am selecting the boys. I have selected the boys. So when you have selected the boys, what will be the probability of the selecting if you have selected the boys that they will got grade A. So I am representing this by A means probability of getting grade A if boys are selected, and the probability of how many boys are there out of 100, 60. So this probability is PB. So probability of getting grade A if boys are selected, this will be given by PAB in PB. Similarly, we will see for girl also, and they are 40%. So this is given PG. And then if you have selected the girl, what is the probability of getting grade A if girls are selected? So this will be given by into PG. Okay? So here it is given that this is 0.6, 60%. Girl is 0.4, 40%. And 8% of the boys got an grade A. So PAB, when boys are selected, this is 0.08. And similarly, if probability of when girls is selected, that probability of getting grade A is 12%. So this is 0.12. So what will be the total probability of getting grade A? This is the total probability. Total probability. PA is given by this plus this. So that will be so this is 0.08 into 0.6 plus 0.12 into 0.4. So what value you will get here? So this value is 0.048. And this is also 0.048, and that will give you 0.096. So this will be the total probability. And You know the total probability of getting grade A. So what will be the probability that the student got grade A and probability that the student is a male? So we have to see this particular value. So probability of a student is a male and provided they got grade A. So this will be given by simply PB by total probability. So we will divide this by its total probability. Okay? So this will be 0.048 by 0.096 and this will be 1 by 2, that is 0.5. So this probability will be 0.5. So option D is correct. Is it clear? Chalo. Now we will see next question. Just see. The you have to find the complex integral. This integral you have to find where C is the unit circle. A unit circle centered at the origin that traversed in counterclockwise. So unit circle is there in XY plane. This is X and Y. This is 1 and this will be 0 here. And let's see this integral I that we have to find. So now consider the function fz is z power 4 exponential 1 by 2z. So let us first write the expansion of this function. This will be z power 4 1 plus 1 by 2z whole square. We have to see at what point there is a singularity and then what will be the residue at that point. So that's why I'm taking an expansion. So you will see, you will get z is equal to 0 as a singular point. So if you write this expansion, because here z power 4, so we are focusing on 1 by z terms. So if you write here 1 by factorial 5, this will be 1 by 2z power 5 plus and so on. So this will give you what? This is z power 4 plus this will give you z cube by 2. This will give you z square factorial 2 whole square and so on. This is z power 5. So what you will get here? 1 by factorial 5 into 1 by 2 power 5 and this will be 1 by z plus other terms. So you will get negative power of z and there are infinite number of terms. So it's a Lorentz series. This fz represents the Lorentz series and there are infinite number of negative powers of z. So z is equal to 0 is an essential singularity. There is an essential singularity at z is equal to 0. So what will be residue? Residue is given by 1 by factorial 5 into 2 power 5. So this is 5 into 4 into 3 into 2 into 1 into 1 by 32, 120. So this is 120 into 32, and this will be 1 by 3840. So integral value will be given by 2 pi iota into residue, because z is equal to 0 lies inside. So this will be 2 pi iota by 3840. So this is pi iota 1920. Pi iota 1920. So option D is correct. Option D will be correct here. ठीक है? चलो. Now we will see next question. So in this question, a gamma function definition is given. Gamma function with argument z is defined by this relation, where z is a complex variable. So we have to see gamma z has which type of singularity. From the same relation, let's check for what will be gamma z plus 1. So by definition, this will be 0 to infinity. You will get dt t power z plus 1 minus 1 e power minus t. And if you take z, is it clear? So what will be relation between gamma z here? So you will see this will be given by z gamma z. This will be z gamma z. And then gamma z will be gamma z plus 1 by z. So you will see that at z is equal to 0, z is equal to 0, this gamma z has simple pole. Gamma z has simple pole. Gamma z has simple pole at z is equal to 0. And it will be also non-analytic at other points, like this will be non-analytic at -1, at -2, -3. That is also a non-analytic point. But here in the option they have given at z is equal to 0 only. So we have to find the correct one as it's a simple pole at z is equal to 0. Is it clear? So we have discussed all the questions that has been asked in the March 2025 question paper of related with the mathematical physics. Is it clear? So in next lecture, we are going to discuss the EMT questions. So tomorrow we will discuss the EMT questions. Chalo. Okay. Thank you everyone. Thanks for watching.